Hello everyone, today I want to show you how to create this tube. We're going to use three.js and let's basically start. First of all, you gotta create index.php or HTML. It doesn't matter depending of which running server you have. And also we're going to create main.js. Now I'll go into my GitHub repo that is going to be in the description and I'll find static-3.js. You'll go into index.html and copy this. If you are concerned what is it all about, you go on the first page of three.js documentation, and it is going to be pretty much the same setup that you would copy from my repo. It doesn't really matter, but if you want to go along with documentations, it's up to you. Now since this one is done, we're going to import everything as 3 from 3, and the last thing we're going to import is going to be WebGL, and we will import it from 3 / add-ins capabilities. Let's check capabilities like this. Capabilities. Wait. Okay, here we are. And WebGL, obviously, .js. Now we're done with our imports. Let's start with our header. As usual, header is going to be a function that is going to be init scene, which stands for initialize scene. And before we are going to declare some variables. The first one is scene itself. Then goes camera and renderer. And since we're going to create tube that is going to be that is going to rotate, we'll just declare it here because we'll use it later. Now scene is going to be equal new 3.scene. It doesn't have any parameters, so you just leave it as it is. For the camera, we use perspective camera from three.js, since it is the most popular camera, three.js, I would say. 75 is basically an area that camera kind of consumes, and also window dot inner width over window over inner height is going to be our aspect ratio, basically the ratio for the camera. And these two last parameters are those that define the nearest point and the farthest point. Then we go to the renderer and we say new 3.WebGL renderer. And inside here, we're not going to do anything, but we're going to set the size for the render, since it's important to know what size we are going to render. And I will say the same size as window.inner width. And as you can see, I made a misspelling here. Yep. And it's going to be, the height is going to be window.inner height. And the reason why we use window is because I want it to be stretched on the whole window. If you would use anything else, for example, the box or container, you would put this, you would find the box with the document query select or something, and you would put it here as well as in the camera, because it's important that they are all related to each other. If you would do here a window and here the container, nothing would work fine. So you gotta be sure that everything is correct. Then we go to the document, but more precisely to the body. And inside body, I want to append a new child. And the new child is going to be the renderer itself, because we want to render it as a canvas. And we're going to append DOM element. Now, that is pretty good. That's pretty much everything we have to set up for our scene. Now let's start our body. The body has this function that is called create objects. And what I want to do first is to create a class. And this class is going to be custom scene or sign curve, and it is going to extend the three.curve class, and we're going to go inside. Then we're going to use the constructor, since we want to know what is the scale person is going to use. So let's say scale. We go into here, curl brackets, and we say this scale is equal to scale. Why do I misspell it? Can't figure it out. Okay. Now we have also we have to use, since we use curve, we are mandatory to use the function that it has, and I forgot the name of the function. That's why we go into documentation, because it is the first source of information we are going to use, and the function is called getPoint. And we go and we declare this function right here. We just kind of redefine the function or something. For it receives t as well as the target. What is it called? A optional target. Optional target, and optional target is going to be a vector. And if I'm not mistaken, yeah. So first of all, 3, then vector 3, since we need 3-dimensional vector, and we say new, right? We go here. Yes, it's equals, and then we go here. Now inside of here we will define 3 constants. Let's make all of them 0 for now. 3 because we are working in the 3-dimensional space. That's why we're going to have tx, ty, and tz. Ty. Tx, let's say it is going to be t multiplied by 3 minus 1.5. You can adjust it as you want later on. Ty, I want to use math sine function, and we're going to pass it inside. And as you can see, we are going to use basically number pi for the sine, 2 pi. So, and as well as I want to multiply it by t. And tz I am going to leave as it is. If you want to, make it farther from the scene or nearer to the scene, you can adjust this value too. I am not going to adjust this value. And at last, we have to return something. And we return exactly optional target, and we set the coordinates. If you would like to use it as like this, return u and then put the coordinates right here, tx, ty, it's up to you. I'm going to use it in this way because this way was provided in the documentation, and we're just going to pass these elements. And the last thing, I want to actually scale it. That's why I'll say multiply scalar. So every single value is going to be multiplied by the scalar factor. And our scalar factor is going to be this scale, basically whatever user use in our custom scene curve as the first argument, because we have only one argument, so as the argument, I can say. It's pretty much well set it up, whatever. Now we're going to create our actual tube. And first of all, we're going to create path, and path is going to be exactly our custom scene curve. And inside, as you may know, I will put the factor that is going to be 10. Then the next thing is actual tube geometry. And inside, so this one is basically pretty much the tube itself, but the tube is the mesh, so this is just geometry, but we're going to say new 3 tube geometry, and inside, as you can see, first thing we have to put path. Okay, now essentially what getPoint does is it goes, so it triggers this function, for example, 100 of times. Okay, and it goes from the range from the 0 to 1. As you can see, a position on the curve must be in the range from 0 to 1, and then it makes all these points go from the range to 0, from 0 to 1. So basically, the first set of points, or if I can say matrix, is going to be this one. For example, the first value is 0, so I would say the first coordinates would be 0 multiplied by 3 is 0, and 0 minus 1.5 is negative 1.5. That would be our x. Our y value would be whatever sine is equal to of negative 1.5, and to be precise, of this 2 multiplied by pi multiplied by negative 1.5. So let's say just y something, and z is going to be 0 always. So basically, the only points that are going to change are these 2 points. And this is pretty much it. I hope it's pretty self-explanatory or whatever. So this is that's the reason why we pass the path as the argument, because it is the big matrix that has all those matrices that runs here from the range 0 to 1. And then we're going to define the tubular segments. Those are the segments that like in the line, like for example, let's say here's the line, right? And how many times you want to divide this line. Okay, so we would say that, let's say 40 times. Actually, never mind, 30. Let's say 30. Now the next parameter is radius, and radius I want to make just to 4. That's I think everyone is familiar with the radius. That means that diameter is going to be 8. So overall 8. And then the segments are, so for example, here's the 3D line, and those are the kind of separation that go along the line. Okay, for example, here's the big line, and how many separations here is 1, 2, 3, 4 separations. So we can do more or less, and this thing I would do 24. Okay, and the last argument we're not going to do because it is closed, and what this basically does is, I don't even know how to explain it. It basically closes the tube. Okay, and okay, tube material. I just want to use the regular mesh material that is, I mean the basic, because there is actually a regular one, right? No, there is no, but whatever. So basic material. And inside of here, I will use color. And the color, let's say green. Let's make ours green. 00 FF 00. And for those of you who do not know, we have RGB, and depending of which color you want to, display, you would put 2F on that letter. So this is R, which is red. This is G, which is green. So that's why all of them zeros except this one, because I want to have green. And this is B, which is blue. So if you want to have blue, you would say green is 0 too, but blue is F. Just for those who do not know this, I think pretty much every one of you know. And the last thing is tube itself, which is going to be just simply 3 mesh. And inside mesh, we will put our tube geometry and our tube material. Okay, so it's pretty much done with the tube. The last thing left is to add it into our scene. So we'll add the tube, and now we also have to think about the camera, since the camera's initial position is 0. That means that our Z is 0 too, right? And Z is 0 too here too. So that means that our camera is right inside our tube. And this is the thing we have to always think about. That's why we will move our camera farther away from the scene, and I would say on 30 points away, okay, or 30 units. And now it's done. So our body is well set done, and we go to our footer, the last thing left, and our footer is going to contain the most functions, I think. So the first function is going to be animate function. Okay, let's go again. Function, animate. Inside the animate function, we first want to request an animation frame. The reason why I type all of this and I don't use the shortcuts is because I want my memory work in this moment so that my fingers will memorize what it is, and when there is no hint here, I will be always able to say it is request animation frame. Because what I noticed is when you use the shortcuts, you don't really think what you type, you just know what it is, but your hands don't know what it is, and it becomes a real problem. But I mean, you can do whatever you want. I just say that as for me, it was a little bit I don't know, frustrating that I didn't memorize anything before, so I started to use my fingers to type it out, the whole thing. Now we added the rotation for y-axis, and actually let's do it for the x-axis, and the last thing left is to actually render our scene. When I say the last thing left, I mean the last thing left in the animate function, okay? So do not think that the last thing left in the whole build process. So scene, and then goes the camera, because these are the essential points for our scene itself to work out, because we want to animate it, right? And then we go and we define the function that is called on window resize. And this function controls the resize of the window. So if window is resized, we have to re-render the whole stuff of our scene. If you don't want this, just skip this function. But as the good practice, I would usually advise people to do this function. So first, we have to change the camera aspect ratio, and we will just change it on the same thing. So what it basically does is that it says, well, at the beginning we defined it as this ratio, so I'm basically doing the same thing here. But when you changed it, nothing, had a track of what inner width and inner height is right now. So it is important to use this as well. And then camera, we're going to update projection matrix. Animated misspelling here, matrix, okay. And we call this function because the documentation says that this function should be called always when the aspect ratio for the camera is changed. And the last thing left for this function is to resize it. And we're going to use pretty much the same thing as here, just because we want to know what our size of the window, what is the size of the window at that point when window is changed. Because later on we're going to add our window listener that is going to listen for changes, and inside of that we're going to actually pass this function that we're just if I can say this, that we're just finished. Yeah, pretty much the last thing left is WebGL, and then we're checking is WebGL available. This is less and less issue in nowadays, because usually everyone has this WebGL available, but in case if someone does not, we're going to handle this as well because it is the good practice. And now we initialize the whole stuff here. So init scene, then we're going to create all the objects of our scene. Because also the reason why we create so many functions is because we want to, we want to have our code, clean. So I think it is important as well. So we do resize, and then we pass the function that I just said a minute ago. We pass this function in so that whenever our window changes, we would change our scene as well. And the last thing left is to animate the whole stuff here. And I believe it's pretty much what this is all about. Oh no, the last thing left is here. So we're going to create a constant warning, and it is going to be equal to webgl dot get webgl error message. Okay. So this is basically the element, div element or something. That's why we have to add it into the document body. And we'll just append a new child that is going to handle this thing as well. Okay, so warning is here. And we're good to go though. So now let's actually run our server. And for those of you who do not have a server or who do not know what is it all about, I think it is important for you to check this video. So how to convert code to web page, or in other words, how to run PHP on Mac. So if you are interested of how to do PHP as, let's say, Misha 70099 or 4 and run this, you would have to watch this video. So I'm just kind of advertising this video because it is really helpful if some of you do not have it. And we have the first error. Okay, I didn't use new for custom scene curve. I think I did the previous time I did the exact same mistake. I have to memorize it. Now we didn't use this for our. Now where didn't we use this? Oh yeah, we have to call super. That's the thing that I also skipped. And it also says cannot set properties of undefined setting C. That means I made a mistake with position, misspelling, position, like this. Okay, and here are our tubes. And this is what this video is all about, I believe. Now, if you like this video, I don't know, just show appreciation. And in the next video, we're going to talk about the lights, and we're going to use this tube as an example. Thank you for watching. Bye-bye.